Welcome to the Green CE movie series. This is part 2 of our case study, documenting the construction of the Health Sciences Education Building. 21 months after breaking ground, the Health Sciences Education Building is just 5 months out from completion. The project is currently tracking at the LEED Gold level, higher than the initial goal of LEED Silver. During design, the team used a series of software analysis tools to model the performance of the building. The result is a unique, energy-efficient building that has been shaped specifically for its site. Andy Lebov from Co-Architects leads us on a tour of the building.
So this is the west elevation of the building, and we actually are here on the around sundown, so you can actually see the sun as it hits the west side of the building. One of the strategies here was, obviously because of the west sun in Arizona, was to minimize the amount of openings and minimize the amount of light or direct windows facing west. So what we do is, and you can see they're under construction, these V-shaped notches that you see in the building right now, those will actually have a series of inset, kind of reverse bay windows, if you like. And they will be clad with a translucent glass that minimizes the amount of direct sun that comes in. That's obviously the library up on top, and it's skylit. And it also has these deep niches that are carved into the west elevation to, again, reduce the amount of direct sun, but still provide natural light. Then what we also have is this copper skirt, which is really actually perforated copper. It doesn't really appear that way from here, but from the underside, you can actually see that quite a bit of light actually does come through, even though it does cast, as you can see, quite a bit of shade and shadow onto the glass in the public space and in the lobby along the sides. So we do have views out on the ground floor. This will be covered in trees, this whole area. We'll eventually have a series of Palo Verde trees planted in a grove, which will also reduce some of the sun that falls on the windows as well. So this is the south elevation. This is the side that's facing south. So what was important here was obviously to control the direct sun, but allow as much natural light into the building as possible. And these are all classrooms and offices along this elevation. So what we did in this case was we started off by basically orienting the building so that the long direction of the building is facing south, with the short ends of the building facing west. And so and that maximizes the amount of daylight and gives us the best ability to control how the daylight comes in. So the way that we control the daylight was from two methods. One was by shaping the building. And the shape of the building is oriented in such a way that by having these ins and outs of the building, the amount of surface that sees direct sun at any given time of the day is actually minimized. So by having some variation in the shape of the building, what that does is, first of all, it reduces the amount of facade that's facing the sun at any given time. So what you can see here is that this portion of the building is in complete direct sun, as is that portion over there, but this elevation over here gets less sun, and it reduces some of the energy load on the wall. Another thing that we did was we also made sure that we have horizontal sunshades that shade the building for a good 6 months out of the year. So right now it's February, and even in February you can see that the sunshades are fully effective and shade almost the entire glass facade, even at about 4 o'clock in the afternoon. And at midday, the glass is completely shaded, even at this time of the year. And that lasts all the way through the summer. Another feature that we have is above the sunshades, you can also see there's a strip window which also has a transom that allows some natural light to get in deeper into the rooms that have taller ceilings in the classrooms. We use the sunshade actually as a light shelf to bounce light farther back into the room, and that's very effective on the taller rooms. You can see these rooms that have the transoms. Those are all classrooms, whereas the offices don't have the transoms. They've got lower ceilings. One more feature that you can see related to the copper, there are 2 mechanical rooms, one on the 3rd floor and one on the 5th floor. And we actually have perforated copper here, which is covering the louvers and the air intakes that bring air into the mechanical rooms that are on each floor, or on every other floor rather.
After establishing the building's form, the design team focused on developing a wall assembly that would provide superior energy performance in the intense heat of the Arizona desert.
So what you can see here basically is the entire wall assembly in all of its layers. And it starts off with the substrate, which in this case is gyp sheathing with a waterproof membrane. And we started off by using a high temperature membrane, but we realized in doing the thermal analysis that by putting the insulation outboard of the membrane, the insulation, which in this case is mineral wool, the mineral wool actually protects the membrane, and the membrane never really gets high enough that a high temperature membrane was even necessary. So what you have here then is the membrane, a series of girts or clips that attach a set of wind girts that support the copper panels. The girts are attached back to the wall system, but there's a set of shims and thermal isolators that keep the vertical Z-girts from touching the wall assembly itself. And that helps to prevent, or reduce at least, thermal conductivity between the metal aluminum purlins, Z-purlins, and the structural studs, which are back behind there. And then for alignment, there's another set of horizontal L's or Z's that then support the copper. What you can see in between here, though, is between the insulation and the copper, there's a 2-inch airspace between there that allows hot air. Basically, this cavity from here to here is a 2-inch airspace that allows hot air to travel and pass up the wall. And so that is generated, that convection is started by perforated copper at the bottom that allows air into the cavity. And that air goes all the way up through and is drawn all the way up through the top of the wall and is evacuated at the coping with a large gap or a large joint that allows air to flow out, hot air to escape through the top of the joint. So basically, when the copper heats up, it basically creates a convection inside the wall that draws air from the bottom all the way up through, all the way up to the top of the wall. And that helps take the heat away from get the heat evacuated before it has a chance to even get to the insulation. And then the insulation then helps to keep the membrane at a constant temperature. So the wall performs better, the membrane lasts longer, and that's it. Okay, so this is the central courtyard, what we call the canyon here in the building. And the origin of this space was really that we were looking for a gathering space for the students. But we also knew that the owner could not afford an atrium and could not afford to air condition a large volume space. And so what we tried to do was to use passive techniques wherever we could to make an outdoor but very comfortable space. And we did that really through 4 different techniques. The first one is simply the geometry of the space itself. As you can see, it's a very long and very tall space. And basically that, in a way, helps to make the space self-shading. The second thing we did was to also put a tensile fabric structure over the top. Now, what that tensile fabric structure is really doing is really trying to reduce the amount of direct sun that comes into the courtyard. It's not really keeping out the rain. It's not acting as a weather barrier. It's really just acting purely as a tensile shade fabric to keep sun out of the courtyard. The third technique that we used is another passive technique, which is to really make the lower walls, you can see on the left side here, and it will be on the right side over there, to make those out of masonry. And the masonry will essentially draw heat out of the ambient warm air and act as a heat sink to reduce the air temperature. And then the fourth technique, which is actually more of an active technique, as you can see along there, we have the air vents. And those are actually the air from the air conditioning system that is exhaust air that would normally be exhausted up at the roof of the building. But again, we exhausted it into the courtyard so that when it's 100 degrees outside, that air is still, maybe it's 80 degrees, it's still pumping air that's 20 degrees cooler than the outside normal temperature into the court at the level where people are actually standing. So the intent was really to concentrate on this first floor and second floor and really make these the areas that were comfortable for human inhabitation. So we're standing in the mechanical equipment room, or the air conditioning equipment room, and there's nothing particularly interesting about the room itself, but the story of how it got here I think is pretty interesting because it talks about the benefits of working as a team and working with a construction manager during design. When we started designing the building, we started off with the air conditioning units up on the roof, which is where they traditionally would end up because we figured that that was the least expensive place for them to be. As it turned out, that was actually making them more expensive, and we didn't quite understand that. But what the contractor was able to point out during the design phase was that by bringing the air conditioning units down and having one on every floor, he was actually able to compress his construction schedule and build the building faster. And that even though it took up a little more square footage in each floor, the amount of time that he saved, which is about 6 months, more than paid for the additional square footage, and eliminated a significant number of shafts, eliminated a large amount of ductwork and piping that would have had to gone up to the roof of the building. So it's a really good example of how the systems themselves are really no different, but by working with a contractor and thinking about construction in terms of time, not only in terms of space, we were able to save the owner a significant amount of money and make the schedule even shorter. School of Medicine library. And what we try to do again is to allow as much daylight into the space as possible, but not have direct sun. So this is actually facing due north. There's actually a piece of wall that comes out this way to make sure that we don't get any west sun. There is some east light that comes in, but generally most of the students here are usually using the building in the afternoon and in the evening. And so we tried to balance the light by having north light here and then having the skylight from what eventually will be a skylight over the top of that staircase when all the scaffolding comes out. And so you'll have light coming from the top and light coming from the north. But again, minimizing direct sun coming into the space to minimize glare, allow students to work on computers, and minimize heat gain, and make the library really what we hope will be a very comfortable place to work in.
Although they will not submit for the related LEED credits, the design team applied strategies for daylighting and views in order to enhance the indoor environment for the students and staff.
One of the features of indoor air quality in the LEED scorecard is access to daylight and views. And so, there's some very simple things that you can do to make sure that you get access to daylight to everybody. And one of them is just simply putting transoms over the top of at the top of the walls. These are all faculty offices. And as you can see, the light that comes in from the exterior wall comes into the corridor and will still come into the other offices from this side as well. So you get a thin floor plate. Courtyard is on this side. The exterior south elevation is on this side. And daylight, depending on the time of day, comes in from both sides into the main corridor and into the open work areas that are at the center of the space. So, something you can do that's very, very simple. It can be very effective. And then every once in a while, we also break the corridor and just have an area where you can get a view out to the outside of the building and eventually down to the offices on the floor below. And there's just one of these per wing, but it's very effective in bringing people together and giving them a space to basically see outside of the building and to see from one floor to the other. So you get access to daylight and access to view with very little investment and very little space, very little cost. And eventually that whole window, you can see the shadow line now of the steel framing, but eventually there'll be a copper sunshade. So all of this south-facing glass will have a view to the outside, but also be shaded. And that will also help, I think, quite a bit with some of the glare.
The LEED for New Construction Rating System addresses the design and construction of a building. While most of the planning is done during the design phase, the construction phase is critical for implementation. If not diligent throughout construction, anticipated credits can easily be lost through lack of follow-through or miscommunication. The team is pursuing 4 LEED credits in the Materials and Resources category. It is the contractor's responsibility to implement the construction waste management plan in order to divert the project's construction debris from the landfill.
So the biggest challenge is getting all the field hands to understand why we're separating our trash and why we have all the different dumpsters how to keep those clean. And it was a little rough in the beginning, but they're really learning it now. And we've kind of set a crew aside. Everybody can bring their trash down, then we have guys that separate it and get it into the proper bins. And it's been working out really good. It's a lot better than climbing in the dumpster and cleaning it out.
Construction waste management, it's always an evolving credit. And when I mean that to us general contractors, there's always something different you can do. The key thing is, what have you learned in the past and what can you take forward? The biggest battle we had on this project was, like the terms usually said, postage stamp site. Very small site with a big building. And so how do you manage waste in general? A lot of moving pieces, a lot of moving equipment, and then how do you find room to have 4 or 5 different 40-yard dumpsters? But for the most part, we recycled all the wood products. A lot of the cardboard and different things went back to like furniture or their own suppliers. But we did metal, gypsum. We had a lot of glass, but didn't have a lot of glass breakage, which is a good thing. And then just general debris. But the biggest thing we did from a waste management standpoint is a gentleman on our team came up with a good idea to not necessarily educate when they first came to site, but to monitor. And that's the biggest concern, is how do you monitor? You can put it in English and Spanish on a dumpster and they get the idea, but how do you monitor what any individual's actually putting into a dumpster? So what we did was we built an elevated platform. And by doing that, it came right off of our temporary elevators. So we had a lot of cleanup crews. We had a standard cleanup crew every Friday, and each subcontractor, based on the amount of people they had on site, gave a certain amount of people to that crew. So they do a clean sweep of the building. When that was done, they would have a lot of large dumpster or large gondolas, which are just big trash bins. They'd bring them down, but then when they brought them out, the elevated walkway we had was about 3/4 the way up the dumpster. So you're not asking people to, throw things up and over or walk it in, and then as it gets full, you have to close the door. We were able to leave the door closed at all times and then have them just gently toss over to the side. And they could easily physically see what exactly they were throwing, which dumpster and what they were throwing in there. The other thing is it gave a lot of eyes to look at it. Any one of us could look at it, or any worker could look at it and help each other, saying that that's a wood dumpster, you shouldn't be throwing that piece of material in there. So that was a different thing that we've done. Some other projects that I've heard some interesting stories on have done where they do chain link fences. If you have room and you have some laydown area, you just build a chain link fence. And then you ask the people to put it in there. Well, it's see-through. So you can obviously see exactly what you're putting it in. And then you have if you have the equipment, you just pick it up one day and send it off to the recycler. We're going to probably be really close to that 75% mark. And on a project of this scale, it's pretty good, with not a lot of heavy steel or anything like that to add to some weight. So I think we're pretty impressed with it.
The design team has prioritized using materials high in recycled content, locally sourced materials, and sustainably harvested wood certified by the FSC.
So the big thing with recycled content is a lot of materials now have some form of it, but it's picking the right material. Which is the right one to use? There's so many different forms of different products out there. What's the right one that fits your building? Some of the big hitters on this one, as we call them, where you get a good amount of recycled content, is you got insulation. We have some countertops that are really high. Drywall, studs, some of and of course the copper on the outside, that's a given. All architectural copper runs at about 99.9% recycled. The other big one is any type, concrete doesn't necessarily have a lot of recycled content because it's fly ash that's recycled. But the key thing is concrete in Arizona is made within a 15-mile radius, and that's huge, just because of the Salt River. And the Salt River aggregates are very, very widely used. They're shipped all over the world because they're so good. They have a lot of color too, so if you do like ground concrete, different things like that, they bring out some nice colors. But the farthest thing is the cement, which comes from Hermosillo, Mexico, normally, or typically. The big thing is it doesn't necessarily give you recycled content, but it's a really good material to use here, just because it's so plentiful and it's so easy to get, and it's really good for the environment as far as a travel distance. With that, everything that you could ever want comes out of the Salt River: the water, the lime, the aggregates, sand, you name it. So that's a key aspect. Some of the other products like drywall and studs, they're local. And so that's another good thing. You're getting both benefits. You're getting the recycled and you're getting the local material. The copper, for example, is a great recycled material. This copper did come from out east, which that's where any architectural copper comes from. So there's not much you can do about that. You're governed by it. But it's a very suitable material, and it's very suitable for Arizona. It gives a lot about back to Arizona because Arizona's named for copper. The other neat thing we have about this one is all of our exterior insulation is on the outside of the building. So normally you're going to do some type of insulation on the inside wall or the outside wall. All of our insulation is actually hanging on the outside of the building. It's a thermofiber product which has a really high recycled content value, and the entire building's covered in it. And so it's great R value too, and it gives a lot of recycled content back. Some of the other big carpet like normal, and then from a regional standpoint, we have a lot of steel in the building. We have a lot of reinforcing steel for concrete, which all comes out of either New Mexico or Texas, and that's completely 100% scrap metal. But we don't have a lot of actual, big iron, which would come out of Pennsylvania or something like that. And so it's really from a local standpoint, we're able to harness a lot of recycled stuff that also benefited from a regional standpoint as well. So we're able to balance the two, if that makes sense. Some of the finishes in the building are a little higher end. When you get into the higher end, sometimes you have to go overseas to get those things. Now, with that, you try to do the best you can. We have a lot of acoustical wood in this building. The acoustical wood does come from overseas, but the finishes on the acoustical wood are all low VOC. So you're not putting something, you're not taking strike one and strike two. You are taking something from overseas, which is a very nice product, but you're taking it in a fact that then you can transform it into a more sustainable manner by putting a nice low VOC coating or paint on there. All the wood that we do have, like I stated, is all FSC wood. So we pay a little bit of a premium for it, but it's, again, for the benefit of the sustainable movement. We have, I would say, comfortably over 95% FSC wood. And when we get our final numbers, there shouldn't be any reason why we're not at 100%. It even goes sometimes into formwork too, of using the right formwork. We use metal forms rather than using wood forms. Metal forms can last a lot longer than when you're forming concrete than a wood form could. So there's a lot of different things that we can do from a standpoint that's not necessarily just a document that says it's FSC, but it's also what else can you do from a wood product style of construction. A lot of millwork that we have quite a bit of millwork, lost a lot of built-in furniture, but a lot of the millwork, every veneer is FSC, all the particle board. It's not a new product, but it's all formaldehyde free. So we're in for the credits, and we really look close to that, and at the beginning had to pay a premium to get those things.
The contractor functions as the overall quality assurance provider for credits related to material content and to VOC emissions. Their responsibilities include review of all subcontractors' submittals and tracking the information for materials installed in the project.
To get documentation in a general LEED sense, that the dollar amount's always a sticky one, because sometimes they think you're trying to get at something else, but you're not. You're really trying to do it for your LEED calculations, because it's all material based. It's not any type of labor or equipment. To try and get the raw material cost, and sometimes it's astonishing because there's so much fabrication that goes into things, and you look at it and say, I'm paying this much for this and it only costs this. But there's a lot of things like in millwork. It takes a lot to fabricate, and to get that information and get it true is the biggest thing you're after. One of the things we did on this project was we had a standard sheet that we sent out, which was in essence a 2-page sheet that had, for every material, it had any credit that would ever be affected. And so it had anything from recycled content, it had the dollar amount, obviously right there, number one thing to ask. It had where any components of that material came from. So if it's something that takes a couple things from here and a couple things from here, well, where did all those pieces come from to find that final component? Had any type of adhesives that were used with it, sealants, was it FSC, was it formaldehyde free, you name it. So that it's a one-hit kind of thing for every product. Every sub can do it once, and then we have every information piece we need from our side so that we can go produce the final spreadsheets and upload to LEED Online for the final review.
The HSEB is pursuing 10 of the 15 credits in the Indoor Environmental Quality category, with indoor air quality being the primary focus. The contractor implements the air quality management plan during construction and oversees and tracks the installation of low-emitting materials.
We required all subcontractors to clean up their own mess or any type of scraps. But then we also had a general cleanup crew. That general cleanup crew went every once a week or twice a week as needed to go through and throw out anything, clean up any scraps, use sweeping compound, sweep the floor so it doesn't create a lot of dust. Arizona's tough to battle with dust because you have blowing dust, you have dust in the air, you name it. And so if you have a storm and you have anything that kind of little haboob pops up, you got dust over everything. And so how do you control that and how do you keep it so that you don't let those things get into a system or even under carpet, for example. You're not putting carpet down over dust. That doesn't make sense. And so doing the typical things in a construction project may not necessarily do the right thing. So we try to take it a step further with the daily cleanup and the different crews. And then also monitoring any duck ends, where if the duck end, if it was going to be leftover lunch, that's not acceptable to us. That has to get covered. You know, we can't catch all of them. It's not you know, you can't do it. It's not realistic. But the big thing is just making sure that you monitor it the best you can so that at the end of the day, they're all saran wrapped, everything, every duct end, every pipe, you name it, all the systems are turned off. We also monitored when they came here and when they shipped here, because the biggest thing is your ductwork. All the ductwork came prefabbed out of Tucson area. When that stuff came, we made sure that it had still had the right wrap on it. I mean, a truck can, I've had a project where it had an air handler and they packaged it wrong and the whole entire top of the air handler blew off because the packaging was wrong. And so when you think about that, the transportation is another thing you have to look at. It's not just when whoever receives it, you have to look at how is it transported and how is it wrapped. I don't want it to be on an open-end truck with saran wrap. It's not really gonna work very well. The other thing is the storage of materials, anything inside the building or outside the building. We made sure that anything outside was on some form of 2x4s, dunnage, 4x4s, whatever it may be, metal racks, you name it. Anything inside, again, had to be on some form of a rack or elevated area. So with that, in case anything came in. One of our superintendents, is kind of a joke, we made a joke about it, but he was huge on making sure tracks, at the bottom stud tracks, were all cleaned out. And if they weren't signed off and cleaned out, we would pull drywall off to make sure that they were cleaned out. So we took it to the nth degree, which is that's the right thing to do. It's not like we're doing anything wild and crazy. That's the right thing to do. So we had the sign-offs helped from certain areas just to make sure certain areas, things were ready. If you're trying to put carpet down, you're still sanding drywall, all that sand has to go somewhere. When we got into more of a finishes stage, everything was all HEPA vacs. So anything that was cut had to be cut with a HEPA vac, or with a HEPA vac nearby, or cleaned up right afterwards. The other thing was we zoned off certain areas when we started to turn systems on, very much like an ice cooler or something where you had the plastic in the front. The other thing we did was took, best way to put it's like a medical booties, the little brown, blue booties. We use those for anybody that walked into a finished space, so that you, A, weren't tracking it in, and then B, you're not damaging products. And so that's some of the different things we did. We did the standard filter changes. That's a given. You have mervates when you turn things on. And even if they were dirty, we switched them. It wasn't like we just did it once, because that can actually damage an AC unit or some type of equipment if it gets too clogged. But a lot of standard practices, but then also taking it a step further, that was one that we definitely double checked as a group and made sure that at least we had it right going into the installation of the product. Once the product went in, the biggest thing you look at is just to make sure that they're using the same material that they said they were going to use. A guy could have a 5-gallon bucket of an adhesive left over from a project that he knows works for that situation, but maybe that's not the right one that we used. And we did catch a few adhesives that weren't the right ones, and it's just a matter of, I'm sorry, but you need to either take it off and cut it back, or you need to replace it, one of the two.
The project is pursuing indoor chemical and pollutant source control. The Gross Anatomy Lab is a unique space that demands high volumes of fresh outdoor air to maintain good indoor air quality.
The Gross Anatomy Lab design considerations were a little bit different compared to a normal lab. We decided to use, on most lab applications, we'll use a dedicated outside air system, and this system is no different. But how we distributed the air was actually what was different in this case. And in this lab, we actually bring all of the air in through through and above a laminar supply above patient tables, and then all of the exhaust is actually brought out through the table. So the system is only on when there's someone on the table. And so we were able to minimize energy by saying, well, if someone is in here, the system is on. But if there's no one in here, there's no reason for the system to be on full bore at its full, 12 air changes that it's required to have. So we were able to turn down and only provide a minimum amount of air supply, and then when it was occupied, turn it on full bore, and that of course is the energy hog. But it's the case with lab space is always, if you can turn it off when it's not being used, you're a lot better off.
The integrated design process that began the early stages of the project continues throughout construction. The approach proves essential in solving the complex configuration of the exterior copper panels.
Another thing that I really like is the copper panels. What the architect's vision was the striations in the canyons up in Sedona and the red rocks, and how the sediment and stuff works in the rock formations, and how do you turn that into something that's malleable like copper, and how do you do that? So we worked with Kovac and developed many different mock-ups to try to replicate that situation. And I think when you see the building as it is out there, they've done a very good job of doing that, and I'm really proud of that. It will be a landmark project here in the city of Phoenix.
So some of the biggest challenges we had on this project was just getting the design completely done before we went into fabrication, because you don't want to be making a lot of this material and not be able to use it. And when you look at the videos and all the fine lines and making sure everything lines up. And then it's a very tight site. And then getting enough people in here and then proper equipment and everything and making them all sing together has been a lot of fun, making them happen.
The main thing that when you look at the integrated design process is, because this is the first time we've ever done a project with Co, especially as DPR Sun. And so what you have to look at is you have to look at the trust, and you have to build that trust to be able to understand each other. The regional boundaries were a little tough at first, just because when you get into the final intricate details of a project, you're looking at trying to finalize pieces, and it's very detail oriented. It's not kind of intense and big picture items. And so to do it digitally was a little bit tougher. So we had go-to meetings and things where we could share information. But the main thing was we found that design charrettes, or exterior skin charrettes, however you want to call it, we were able to bring everyone to the table for a day, 2 days, 3 days straight, where we picked an aspect like waterproofing and we worked straight through it. And we didn't go anything further. We worked through it, and we sat there for 8, 10 hours, 12 hours a day in a conference room as a group, whipped the plans out, started doing sketches, 3D sketches, isometrics, whatever it may be, so that we could have an understanding as a group. And that was a key thing. And when we did that, that included also our key subcontractors as part of that design assist, so that they understand leaving there what they were supposed to go do in the shop drawings, the production engineering, and all the different phases. During that, we were able to build some trust. And when we built the trust, it made things we understood what they were looking for, and they understood what we could provide them.
The owners value the benefits of third-party commissioning and have chosen to pursue both fundamental and enhanced commissioning.
The scopes that were commissioned on this project were the building envelope, mechanical systems, which include the heating hot water system, boilers, heating pumps, and recirculation pumps and whatnot. Also the chill water system, which heat exchangers, again, distribution pumps. We also did the domestic water system and lab plumbing systems, verifying piping, verifying equipment, water booster pump and whatnot. We also did electrical systems, lighting control system, verifying the lighting aspects, also the power systems with your SES, generators, switchgear, and also the monitoring of it. So all those items will be tested by the commissioning authority to ensure that they meet the basis of the design and the intent.
The contractor must plan carefully for the commissioning activities in order to avoid delays in the construction schedule.
Actually, by having the commissioning agent on early and having the collaboration in place where we shared the construction schedule throughout the process, and we kept an open line of communication, started our meetings early in the construction process, we really had little impact from the commissioning schedule.
The commissioning process requires the participation of multiple team members.
So with the commissioning agent, obviously they're the ones that are in charge of leading the commissioning effort, having manuals put in place to describe the commissioning efforts, producing your pre-functional checklists for the subcontractors to start their pre-function, and then also providing the functional testing in addition to the verification and also ensuring owner training. With us, the general contractor, we're basically the central hub, I would say, for the information. We're like the liaison between the commissioning agent, the subcontractor, the owner. We help also facilitate the meetings and also ensure that we're getting the proper information for the commissioning agent to pass on to our subs, in addition to returning that information in a timely manner to the commissioning agent. And with the subcontractors, basically their responsibility is to implement the basis of design, install the equipment, and help confirm the operation of the equipment with respect to the basis of design and design intent. And then the manufacturers and vendors, they're always required at the time of startup to start up their equipment. Also, there's information for them to fill out as far as pre-functional checks, and they have their own startup checklist that they usually use. With the functional testing, it's a good way to really flesh out any installation and or design issues. Sometimes there's a design that might not quite work, and the commissioning agent will help flesh some of those items out. For instance, on this particular project, we're currently having issues with our boiler header set temperature and the way it's working with a control bypass valve in relationship to the boiler and the pumps. So what it's doing is we're supposed to be running at a certain set point, but as flow increases, they're having some variance that's not quite working the way it is. So what the commissioning process does, it helps flesh out any design issues or installation issues, gives us an opportunity to sit down with the team. At this point in the project, we were having 2 commissioning meetings every week to ensure that we were addressing these items in a timely manner. So by Jerry, our commissioning agent from GLHN, he did his functional testing, found that there was an issue with the heating hot water system. We addressed it in the meeting, and now it's back in the design team to kind of basically give us their input. And at this point, we've had the design team online, we've had the commissioning agent online, we've had the boiler manufacturer and pump rep online, and then basically all the parties. And we sat down and just, hey, how are we going to do this? The commissioning agent gave his proposed fix. The AEI, who is the engineering firm on the job, they took a look at it, and then they're going to respond with a proposed solution. So
it is essential to make sure that the people who are going to operate the building understand it. A thoughtful training process will enable the operating staff to optimally maintain and run the building.
Our goal was to have the owner training completed prior to occupancy, which sometimes it does not happen, but that was our goal on the project, and we were able to do that. And basically, we implemented a training process where we provided filming of all training and manufacturer and or subcontractor instructions to the owner on how to operate the building. Bring the commissioning agent on early if you're doing especially a project that's a larger project that has a lot of MEP utilities and equipment. And pretty much that's it, and just monitoring the indoor air quality and making sure that that's in place. And that was another big thing that myself and my project engineer, Scott Jones, did, was really take a strong role in ensuring that the indoor environmental quality with respects to the credit was being followed, making sure that we had our construction filters, the right MER rating for the pre-filters and the construction filters and the final filters, ensuring that the areas that are ready to be blown down, because that was another big item, was the blow down at the end of the project, ensuring that our schedules and the communication is there with the finished trades so we can start, we had to start our return. That was one process, and then at that point, all the, the VOC type work and a lot of the dust producing work had to stop. But then when we started our blowdown period, that was even another aspect of it where we're just blowing everything out, and at that point, the painting, the dust work, everything stopped. So with a tight schedule at the end, you could get into trouble with that. So indoor air quality management I think is a real big one.
By installing specialized metering equipment and implementing a measurement and verification plan, the owners will be able to closely monitor the energy use of the building. The collection of this data will enable the owners to optimize the operations of the building and provide a benchmark for designing their next project.
Measurement and verification is being implemented on this project. It was a really big part of this project. It was the University of Arizona actually requested that we put it in. It's a great concept to do as is, but it's even better when the owner requests that they can do it. For electrical, each of the main panels the distribution panels is being monitored, separating lighting and power, so you can actually view what power you're using for your lights and what power you're using for plug loads and other tasks. For mechanical systems, the chilled water is being monitored, so you can tell how many ton hours you've used of chilled water, of cooling capacity, which also helps for utility bills. But it also helps the owner track and compare, say, when they want to do a future project, that, okay, well, HSEB is this big, and here's what we can expect to pay, here's what we can use in the future. On the domestic water side, the plumbing side, there is a sub-meter. Even though there's a water meter, a utility meter at the building, at the entrance, the owner still requested that there be a sub-meter, so it feeds back to their building control system, so they can actually monitor what water they're using, and then also a natural gas sub-meter for the same application.
I'm Peter Berg with DPR Construction. I'm the project manager on the University of Arizona Health Sciences Education Building. And I'll be taking you on a tour of the building today, highlighting some features that I think are interesting, important, and sustainable. Just to give you a little background on the campus here, the HSEB, Health Sciences Education Building, it's an expansion of the current or existing University of Arizona College of Medicine here in Phoenix. In 2005, the University of Arizona, they decided to expand from Tucson into the greater Phoenix market. And the reason behind that is Phoenix was the only major metropolitan area in the United States that didn't have a medical school to serve the large population. So they chose this site because the city of Phoenix, they actually own all this land here, and they designated it as the Phoenix Biomedical Campus. So the medical component of that matches really well with the University of Arizona College of Medicine. So what they'd done is there were three existing historic buildings, the Phoenix Union High School, that were built in the early 1900s, and they had fallen into disrepair and really weren't being used. They were abandoned, and they saw that as an opportunity, a unique opportunity to expand or build their medical school. And so that happened in 2005. And once that project was complete, the enrollment there was quickly filled. I believe it had a capacity for 40 students, and they saw a need for an expansion. And also the three buildings, they have a relatively small footprint, And the idea is to expand it to create more of a campus feel. And that's really what a big part of the mission of this building was, in addition to increasing enrollment. So when you look at the three buildings there, this is considered the main entry or the main lobby because it creates a transition from the initial College of Medicine and ties it to this new expansion. Something to note about the cast in place exposed concrete walls. Early on, there was a desire by the architect to have it be constructed as a formal architectural concrete. But when we're designing and costing the building collaboratively, between the contractor and the architect, there's always this tension between the desires of an architect and also the cost of the project. So we spent probably 6 months building mock-ups, and we built four, I think maybe 5 cast-in-place mock-ups with different types of finishes to develop a concept that was mutually agreeable between the desires of what the vision of the architect was and what the budget could afford. And this is the result of that painstaking effort. This is the communicating stair. We have code required exit stairs. So this stair technically is not required. But the designer, they wanted to kind of create a connectivity between the different floors and the different disciplines. So what we call this is the communicating stair. And one of the really neat things about it is if you'll notice, at each landing, there's a table surface and chairs where students can actually study on the landings. So we've kind of taken this space that normally is just used in passing, and we've made it a space that you can actively use over time. And kind of an interesting story about this is when budget dollars are competing for other resources in the building, there was some debate about whether or not the intermediate landing study areas were absolutely necessary. But to CO's credit, they really stuck to their guns on that one. They thought it was a very important feature to this communicating stair. And we ended up finding the budget dollars to cover it. And in hindsight, we look at that debate and realize that they were right. This is a great feature of the building. So the concrete floor, there was some debate about, the finishes that would be in the lobby areas. Are we going to go with a tile? Is it going to be a poured in place and ground terrazzo? But ultimately, what was selected is this is just structural concrete that ended up being ground and polished, and then just for maintenance purposes, on occasion, they'll coat it with kind of a wax coating, just to maintain the durability of the floor. But when you look at it, with all the ground aggregate and kind of the random pattern of it, it sort of has a terrazzo feel. It's just structural concrete.
Cut deep into the 6-story mass, the canyon is the central organizing feature of the Health Science Education Building. This shaded, serene space provides a delightful respite from the intense sun and heavy traffic just outside.
All of the interior materials used in the construction of the building, whether it be the wood, any of the laminates, the carpet, paint, all the materials are no VOC emitting materials. So even though we've just finished constructing this building, I mean, you can smell the air, and you don't smell that new building or that kind of new car kind of smell, which would normally be those VOC chemicals. So that's one of the LEED aspects or the indoor air quality aspects that are built into this building. We're on the second floor, North Tower, in one of the classrooms here. And it's, as you can see, I mean, it's highly mediated. All the desks are powered. All the teaching nowadays is laptop driven. There's sort of this trend. There's this trend towards greater automation. But what we found is the more automated the system and the more complicated the system, the less they actually use it to some degree. So now what we found is there's kind of a trend towards more of a simplification of the systems. So for instance, these shades, they could be automated to the position of the sun and that type of thing. But for classroom purposes, they're motorized shades, but manual operation gives them more customization than an actual more expensive automated system. The gentleman, Kevin Seigert, that I was talking to, when you all were setting up, he's responsible for the College of Medicine's audiovisual. And he talked about the Crestron controllers that control the audiovisual in all these rooms. And the first thing that the audiovisual consultant and subcontractor talked about doing was creating this really complex and elaborate menu system. And Kevin, through his experience and all the projects that he's worked on, and has become wise and realized that he wanted it as two-dimensional as possible and as simple as possible. Because as smart as we all are, and as all these instructors are, they're smart in their discipline, but not necessarily on how to operate this really complex audiovisual system. So we've tried to kind of continue that philosophy throughout the building.
The high-tech auditorium classroom is finished in a variety of environmentally friendly materials, many of which exhibit multiple environmental attributes. Acoustical treatment of the walls include wood paneling that is from FSC certified wood and CMU masonry blocks with sound dampening slots. The carpet has high recycled content and is rated as low VOC. The concrete throughout the building comes from local sources.
We're in the level 4 North Tower. This is a simulation room, and the whole fourth levels is considered simulation. And what that means is this is a simulated operating room. They're not going to operate on real people here. They have mannequins, the computerized mannequins, that will be operated on. And as they operate on them, the mannequins will respond in different predictable or unpredictable ways. And that data is collected in a computer to grade the student on how well they're performing. And then once they're done simulating an operation here, they'll go across the hall to the debriefing rooms to analyze and again critique how well they performed. We're on level 3, North Tower. This is the exam room level. An exam room, not to be confused with taking a test. This being a medical school, the med students, they practice being a doctor like in a normal doctor's exam room in these rooms. And what they do is they film them while they examine mock patients. And once they're done with the exam, they move across the hall here to the debriefing rooms. And then they kind of critique and break down how well they went through the exam. We're on level 5, which is where all the office administration for the building is situated. One great feature about this administrative space is all the daylighting. And there's a lot of really nice architectural details that facilitate that daylighting. And one of them is this continuous glass transom that spans the whole length of both corridors on this floor. And what that does is it brings the light in from the glass curtain wall or the windows outside, and then it passes it through the top of the wall so that the drywall doesn't block it out. On a lot of buildings that aren't LEED buildings, they would just continue the drywall all the way up to the ceiling. And that's great for the person on the perimeter offices, but what about all the people on the inside of this space? We're on level 6, it's the gross anatomy level. This is where the medical students work on cadavers. What you see around me are ventilated tables. And the tables actually have an exhaust where they suck the fumes off of the plane of the table, underneath the table, back through the ductwork, up and out the building. So it's quite a complicated space to put together, but necessary for what they're performing here. You also see the lights for when they're working on the cadavers. And then it's a very highly mediated space to capture any of the video footage, any of the classwork, so they can review it later after they're complete. LEED to me is important because we are all creatures of habit. And the design and construction community in the past, we would use the same processes and the same design assumptions and the same construction means and methods over and over again because it's easier that way through habit. What LEED does is it creates a framework to challenge those past ways of doing business. And it challenges us in those areas of consumption, reducing waste, and trying to help us design and construct more sustainably. And then the other component of LEED that's not directly related to sustainability is the comfort of the people actually living in the spaces, the daylighting, the low VOC content, the places that we're working in. They become more sustainable to us as people.
The Health Science Education Building is currently in the construction phase review for its LEED certification. The building's first students began taking courses in the building in late July 2012. The vivarium structure adjacent to the building is also undergoing LEED certification, using the same LEED campus approach.
I think the University of Arizona really was hoping to construct a building that not only would allow for the expansion of the medical school. Certainly that's our first goal. We need to educate more students to create more physicians for the state of Arizona. But we also want to create a great educational setting. Anybody can build classrooms, anybody can build lecture halls, anybody can build gross anatomy space. But to do it in such a way that does allow for the welcoming of all students, no matter where they are, no matter what they're doing, no matter how long they spend in the facility, you want them to have a good setting that just is conducive to learning and just conducive to training what is a very, very important profession for all of us. You want to train the best doctors, you want the best doctors, they're going to take care of us all.